In this lesson, we're going to learn about the future value of an annuity. So before we can get into that, let's go through a lot of definitions here. So the first definition we need to talk about is return. A return is the percent increase on an investment. Okay? An annuity is a series or sequence of equal payments made at equal time intervals. An example of an annuity would be an IRA or an individual retirement account. Now, to save for retirement, you might decide that you want to put $1,000 into your IRA each year until you retire. This series of equal payments at equal intervals is an example of an annuity, saving up with equal payments at an equal time for something in the future, like a retirement. So the value of an annuity is the sum of all deposits plus all of the interest that was paid and earned during that time. So the formula for a value of an annuity is S equals R parentheses 1 plus I to the n minus 1 all over I. We also see that I is equal to R over M and n equals m times t, so those are the same as before, but there's a lot of new things here, s and r, and so we will discuss what all those new variables mean in just a moment. The next thing is interest on an annuity. Now, the interest equals the value of the annuity minus the total deposit. So after you get all of you find out what the value of the IRA is totally worth, and then you subtract off all the things you paid into it, then all you'll have left is the interest. So the total deposits is going to be R, which is your recurring payments, times N. So your interest will be S minus RN, which is another formula that we are going to need when we're solving some of the problems. To go through these variables, S is going to be the future value of your annuity. R is going to be the recurring deposits or periodic payments. Now that's different than present value because when we were doing present value in compounding interest, that was when you only put your money in once and let it sit there. Here the R is recurring deposits, so you're putting that money in every month or every year or at a equal interval. And because you're continuing to put more money in, it changes the formula. R is annual interest rate again. T is the same, time in years. M is the total number of compounding periods in 1 year. N is still the number of total compounding periods over the life of the loan, where we find that N equals N times T. And then I is the same, interest rate per period, where I is equal to R over M. So there's a lot of things the same here. The formula is different, and the S future value and the R recurring deposits are a little bit different. So let's go ahead and try one of these examples. At age 30, to save for retirement, you decide to deposit $100 at the end of each month into an IRA that pays 9.5% compounded monthly. So let's go ahead and list out all the things that we're going to need to find here. So S is going to be the future value, but we want to know how much we'll have when we retire at age 65. So S is something that we don't know. We're trying to figure that out. How much are you depositing each month? R. Well, it looks like we're depositing $100 each month at the end of each month. R is going to be the 9.5%, so that's 0.095. T is time. Well, how long are we doing this for? Well, we started at age 30 and we're going to end at age 65. So if we take 65 minus 30, that tells us we're going to be doing this for 35 years. Let's see, M is compounding monthly, so monthly would be 12. To find N, I'm going to take M times T, which is 12 times 35, which is 420. You can use a calculator to get that. And then I is going to be R divided by M, which is 0.095 divided by 12. So I need to get a calculator out. And you can probably see your formula up above, but I can't, so I'm going to go ahead and rewrite it here. Notice we have the bracket, which is an extra set of parentheses, 1 plus I to the n minus 1. All of that's over I. Okay, so I have S is equal to R, which is my 100. Then I have a big set of parentheses. In the numerator, I have a bracket, parentheses 1 plus I. Now my I doesn't divide out nicely. 0.095 divided by 12 is not nice. So I'm just going to go ahead and put 0.095 over 12 raised to the n, which in this case is 420. Then we have minus 1, and then it closes that bracket. Over I, which is 0.095 over 12. Notice I had to put that in an extra set of parentheses because I want to keep that together on the denominator. So when I type this in, be very careful how you type this in. Every single time you see a parentheses, you're going to type a parentheses. So we have 100. Open that first set of parentheses, that's this parentheses right there. Then I have a bracket and then another parentheses. So that's another parentheses and another parentheses, because bracket and parentheses are basically the same thing. Then I have 1 plus 0.095 divided by 12. Close that parentheses. Then raise, so that's exponent 420. Now, because mine's up high, I need to hit the right key. Some calculators just have a caret key and you don't have to get out of the exponent, but mine does. Minus 1, and then the bracket. So we're closing that bracket. Then I'm dividing by parentheses 0.095 divided by 12 in the denominator. Then I have another parentheses closing the entire thing. Now, if I've done this correctly, it'll give me an answer. Now, if I didn't type in all of the parentheses correctly, sometimes it will give you an error because it's confused because it doesn't have the right number of open and closed parentheses. But in this case, it did. It gave me 333,946 and 29 cents. We can round that up to 30. So this is the value of my IRA when I retire. If you put in $100 at the end of each month, this is how much you're going to have at age 65 if you started at age 30. Now, how much of that is interest? This is an interesting thing to note. So we know that interest from our formula above is equal to S minus R times N. S is the 333,946 minus the recurring payments. You have $100 every month times, you did that for 420 months. So if I just take 100 times 420, it turns out that you added $42,000 to your annuity. But remember, you had 333,000. So if I take my total value, 333,946, and I minus the 42,000, which is really the only thing I actually paid, this gets me 291,946 and 30 cents. This is all interest, my friends. All of that is what the bank paid you to let your money sit there that long. You only paid 42,000 in your recurring payments, but you have $291,946.30 in interest alone. Time is so critical when you are trying to save up. So if you have an opportunity to put away money when you're young, it's going to say you're going to earn a whole lot more in interest than you will just in what you're paying each month. So this is a really good plan to start young.